I'm Daniel Skuka for ESA Web TV. We're in Belgium at the European Space Weather Week, Europe's largest scientific gathering focused on the topic of space weather. 3 of the participants have agreed to join us today to answer questions on space weather. Alexi, how does Europe distribute its space weather data?
Well, in Europe, we have considerable need to distribute space weather data. We have end users and people that need to work with that data from the very north of Norway down to the Mediterranean region. And so we also are collecting data from a variety of space-based and ground-based sources. What we're doing within the European Space Agency is leading the development of the world's first distributed space weather service network. So what we do is we work with our partners within the member states, experts, data owners, modelers, and teams with detailed knowledge of space weather, different aspects of this system. And we bring these different elements together to form tailored services that actually target these end users. These might be users from spacecraft operators through to power distribution networks. And what we do is we bring together the data, the information they need, combine this with advanced modeling, processing, and importantly, expert user support, and provide that in the way that the users would most like to receive that information.
Alexi, thank you. Yes, the sun is ultimately the source of the space weather effects that we see here on Earth. What are you trying to understand about the sun?
Well, yes. So for many people, the sun might look like a dull object, just rising in the morning and setting in the evening. But for solar physicists, it actually displays, when you look at it in detail, it displays a lot of fine structure on fine scales, at least compared to the sun. And also these fine scales are dynamic, yeah, on time scales of orders of minutes to hours even. And that would be an interesting subject just for solar physics to investigate, but ultimately that is important because it drives and it triggers eruptions, so sudden releases of enormous amounts of energy, so that create a variable space environment around the Earth, and it's by that variable environment that Earth is impacted and that our technology sees the impacts. So it's by investigating all these features and these dynamics on the sun that we try to predict the impacts on the Earth, and by monitoring the sun continuously to keep an eye on these structures, how they evolve, what are their characteristics. By investigating all these aspects, we forecast what is going to impact on Earth.
Thank you. And Kirsti, these fabulous green, blue, orange lights we see in the sky, the aurora, what are the aurora?
Well, auroras are the beautiful face of space weather storms. So the ugly part are the problems in the technology, but auroras are the beautiful part. So they are a sign of particle precipitation to upper atmosphere. And the light of auroras comes from the same mechanism as you see in neon lights. So it's due to collisions. So electrons precipitating to the atmosphere collide with the atmospheric particles. The atmospheric particles get excited, and when they get relaxed, then they release a certain amount of light with certain color. And that's auroras. And auroras, the more south you see auroras, the stronger storm we have ongoing. So typically you see auroras in northern parts of Europe, in nominal conditions. But when we have a strong storm, then you can see auroras also in kind of mid-latitudes and in some cases even at low latitudes.
Alexi, Jussi, and Kirsti, thank you very much for speaking with us today. I'm Daniel Skuka for ESA Web TV. For more information on space weather, access our website at www.esa.int/spaceweather. Thank you very much.